Okay, so today we got another medium problem because I don't have time, but this is the first one I drew, so I'm taking it. You are given an integer number and an integer array maps and integer characters is the partition maps into one or more non-empty contiguous segments. The difference between the maximum is at most greater than the total number of ways to partition maps under this condition modulo 10 to 9. Okay, so I mean you could backtrack, but clearly the number of positions is too high. And what we are interested in is that, because if we k is 4, so if we compute the maximum number of contiguous segments partitioning this into blah blah blah, then if we compute it, which is like, or the number we can partition it in, which is 1 and 2 ways, then when we get to 3, our options are that we we can have this one partition and this whole thing, or we can take these two numbers and get the answer for this part, and these three numbers and answer for this part. Now what we want to sum is this plus 1 plus this plus 1 plus this plus 1, and that's it, I think. So answer for this plus 1, answer for this plus 1, answer for this plus 1. Now what is this range? How to even do this fast? Well, we can see that this range, if we move to index 0, we also want the largest integer such that we want to find a largest subarray starting from here which satisfies that condition, and it will be at most up until the position of largest subarray satisfying this. That is because if this number is inside of the min-max range, then nothing changes, and when it is outside, it can only shrink to right. So we have sliding window for the values that are inside of this window, and what we want to compute, so we need to know the plus ones. As you notice that the plus ones, there was this plus 1, this plus 1, this plus 1, this plus 1. So this is the size of the window up until here, so this plus 1, this plus 1, this plus 1. So it's the size of the window is for ones, and then we need to prefix sum this. We can compute this with prefix sum on the number of ways. So that's it. That's what we need to do. I mean, I guess let's do Python, why not? This should pass the time complexity is going to be O, and since the pointers go through all positions at most once, and we do O1 work for each position, and we just update the cumulative prefix sums. So let's do n initialize nums, and then what we do? Well, we need to have some dp of length n plus 1, and we need to have some, do we actually need, I'm just wondering whether we need the prefixes of the dp separately. If we we just cannot calculate them on the fly. I guess let's calculate them separately. So number of ways to make 0 elements is 0. So okay, so we need to keep some LR. So left pointer 0, right pointer 0. And now we go, no, just left pointer and right pointer we iterate. Well, we need to keep minimum and maximum. So if we store the minimum and maximum in a heap or in a set, so I'm gonna use C++ after all. It was size vector, so this goes in mod 19 plus 7 and then vector long dpa plus 1 and pdpa plus 1, and then we need 4 in L0, R0, R is under N and R plus plus. We need to maintain a set of the vertices, so set the values we have. We actually need a multi-set because can it be duplicated? Will it have duplicates? Will it not have duplicates? We don't know. So what we do? Well, st insert nums r, and now while st r begin minus st begin over k. This loop will never crash. It would crash if the cell would be empty, but it will never be empty because if we have one element, the difference is going to be 0. So which is definitely smaller than or equal to k no matter what the k is, which is 0 at least. So we do st erase st over bound, so just one occurrence, not all of the occurrences. So st erase lower bound of, I'm not sure this is not log squared, but this is the way I found out about how to do this. So for now let's do it like this. So let's remove, or maybe just remove the begin element. No, begin. St over bound nums L plus plus. Okay. And now after we've done that, we moved L, so L is now pointing at the position it will jump from here to here. And now dp r plus 1 is equal to pdp from r to pdp L plus size of window plus 1, I think, and then pdp is equal to pdpr plus 1 is pdpr plus pdpr plus 1, and then we return dpn, and we make this, so this subtracts, but this pdp is larger than pdpl, so that's gonna be positive, and this is also gonna be positive. Let's make it long in case we overflow. I mean, this is gonna be int, and this is gonna be int 2. This could be at most Let's just make it long, why not? So, and let's do it modulo this, so it is long 2, and then percentage mod, boom, wrong answer. That's interesting. So BP R plus 1, BP R plus 1. Let's check what it outputs. So there is one way to make this. There is also one way to make this, because we cannot tear this up into a single one. This should have 3 ways. That is 1 way, 2 ways, and that's it. So I'm not sure why there is 3. I think because this is the valid window, so it gets one from here and then one way from here. Number of ways to partition, so actually this should not be here, I think. Just this is enough. The plus ones was not necessary. Okay, well let's axe. The number of ways is so I guess okay, I see what the problem is. We never initialize it. So maybe if we set if st insert equals 0 and we start from 1 and we do like r minus 1, is this gonna be valid? Not really. BP1 is 1. Oh, I know what's the problem. There is one way to make 0 elements. BP0 is 1 and then BP0 is 1. This might work. Still 0. That's interesting. If I set BDP to 0, will it work? No, it doesn't. For auto x BP, so for auto x BP, so I have typed this so many times that I can type it fast actually. That kind of sucks. But it's so L R P B R PGPL. Don't tell me it's always 0 and 0. If I say this is 1, then it also doesn't work because it's gonna subtract 1 from 1. Okay, that sucks. Think about you are here. What you can do? Well, you can get some of these partition number of partition this and then partition this. There's a number of ways to partition this, and then so you want everything in the window. Maybe that also didn't work. Okay, that's just plain stupid, bruh. Hell no. Let's make it quadratic because why not? For now, let's make it quadratic. So we need to go through all positions in the window. So I is less than or equal to R I plus plus, and now dpr plus 1 dpr plus 1 plus dpi percentage mod, and pgp is not visible. This will work, but it's quadratic, but it's what we need. This is what I need exactly. Now let's solve L R including. This will work, but we just deal it. 0 0 1 1. So it's from 0. Maybe this should start at 1. That is interesting. Well, you can either partition all by 1 or you can partition the whatever. Is it correct? 1 1 1 2 4 6. You're interested in 0 1 2 3 4 3. So you can only, you wanna tell me you can only pair these? No, you erase this and you got here. That is weird, bruh. Okay, 9 and 9. Then you move the window 4 and 4. Then it's 1 and 4. Then you move the window 1 and 4. And after 1, 3, it's 3, 7. Okay, that's fair. So the window you got is 2, 3, 1, 2. That's weird. LR. So first you got a window of. Alright, that's weird. Hell nah, man. Hell nah. So you do this minus this. In the previous window you do this minus this. In the previous window you do this minus this. And then in this window you do this minus this. Okay, that doesn't make sense at all. I think I know what is the problem. That if the size of the set is 1, ngpn plus 1, and this should be ngp0 is 1, I think, maybe, I don't know. And now if st size is 1, then you just wanna add the previous thing. So gp r plus 1 is equal to pgp, no, you wanna do this, it's equal to st size 1, then you do gpr, otherwise you do pgpr minus pgpl percentage mod, and then pgpr plus 1 is equal to pgpr plus gpr plus 1. Okay, pgp is not defined, that is great. Let's see, only 2. Let's solve the window. So let's just solve gpr plus 1. Well, I don't need it actually, it bothers me there, so well, the prefix sound works, but that doesn't tell me much, does it? Okay, so first the dp is one way, then it is one way, but here on second element, no, here it should be 2, 4 and 6. So 2 on fourth element, it should be when? So 2 on fourth element. Good question. of set should give me, well, LR is this, should be R minus R over 1, maybe. Okay, well, so at 1 3, that's the 5th number, so 1 2 I think, because we are at 3rd position here, so it should be PGP of 2, so that's one way of making this. Take the number of ways of this, or take the number of ways in this, so then it's L minus 1. Ah, that's bad, bro. It still has not moved the same PGP L minus 1, and then this should be R is L or L is 0, maybe. Okay, now this case doesn't work. Well, immediately this should be 2 ways, so already the second number should be here too, but I'm gonna take what PGPR what the hell? So I said this, and then I'm asking for this actually I'm asking, because L is 0 here, so I'm asking for not GPR but PGPR. No, because this, otherwise L0 GP PGP R, otherwise that. Okay, this is the worst case work of all time. This is not gonna pass, for sure. For sure it's not gonna pass. There is no way this passes. What kind of distribution is that? I mean, maybe I could modulo this, but I mean, it will only overflow 10 to 80, so it's fine. All my days. Sliding EP, I guess. We keep, okay, so DPI is the number of ways to partition the first I elements. The current element can have a own partition or a partition with the previous element, blah blah blah. blah blah. The current element condition is satisfied for each option. We just sum its dp values. Option, we just sum dpi is then sum of ways to partition the rest of elements for each. Is then sum of ways to partition the rest of the elements for each something is then the sum of ways to partition the rest of the elements for each possible for each partition with psi. Notice that the window, the left side of the window for the current notice that the left side of the window for what? Notice that the left side of the window for element for each element is smaller than or equal to the left side of the window for element I plus 4 I plus 1 element, i.e. it does not expand to right. Therefore we just maintain the current window with a multiset in C++. To calculate the sum fast, we can use prefix sums over the required to compute dpi. Fast, we can use prefix sums over the dp array itself. Time complexity of n log n, since we insert and remove each element to the 2/ from the multiset at most on times, and each operation has a time complexity of O log n. For each right side of the window, for each position we do O1 of work calculating the current dpi and updating the prefix sums of dp. Okay. maybe we can do it faster if we sliding window minimum, sliding window maximum. Since we have two DP, two auxiliary arrays of length ON, and a multiset which has at most ON elements at one time. Complexity note: we could maintain we can solve sliding window maximum and minimum with DQ in ON time, giving which would allow us to solve the problem in O1 ON. That's it. At least I think. At least I think it's usable for this problem. Post. Okay, I mean the idea was simple and I just struggled with these indices, but I don't have time for hard problems right now, so maybe on Friday. Goodbye.